Hey, welcome to your deductive geometry practice test. Hey, this is about similar triangles, congruency, and how we can use those to develop theorems on circles and angles in the same segment and all that stuff. So I hope you've revised all of that and are ready to go. So how this works is I'm going to take you through question by question, and you pause the presentation and do the question, and it's 45 marks, so you want about 45 minutes in which to do this practice test. And then at the end, when you've finished, I want you to keep the video rolling and watch me do the questions one by one and assigning the part marks so that you can then mark your work. Okay, so that's the idea of it, and give yourself a total out of 45. So here we go. So start your time now. Here's the first question. Write down the abbreviations for the 4 tests for triangle congruency, worth 2 marks. Pause it and have a go. Come down, question 2. 2 of the 4 triangles below are congruent. Circle the appropriate 2 triangles stating why they're congruent. Don't forget those reasons from back in question 1. Let's go then to question 3. Quadrilateral, calculate the value of P there. Okay, have a go at that. That's worth 4 marks. Show that the following 2 triangles are congruent. Okay, still on that same theme, and that's 3 marks. Let's go down here in question 5. Given that the following triangles are similar, circle the correct ratio. And question 6. State whether the following triangles are similar or congruent and give a reason. Reasons are important in deductive geometry. Okay, so try and do that all the time. And that's 3 marks down there. Okay, question 7. Shape below contains 2 similar triangles. Determine the value of x, showing clearly you're working out. Okay. And question 8. Part A. Prove that triangle ABE is similar to triangle CDE, giving reasons again. That's important. 4 marks. And part B. Hence determine the length of the side marked x. We'll have to go back and look at the diagram again there for that one. Coming down, question 9. Find the values of the pronumerals in the following figures. Give reasons for your answer. So these might involve more than one step. So each time you make a deduction in deductive geometry, you must put a reason. And the other 3 parts of that one. This total question is worth 15 marks, so it's a fair bit of work there. I think this is the last question. The diagram below shows a quadrilateral with both pairs of opposite sides equal. Show that it is a parallelogram. And that's worth 5 marks. So how'd you do? I hope you got something right there. And we're going to go back now and have a look at the solutions to it. So I'm going to take you right back up here to the beginning. And let's do it together now. Okay, so first of all, put your name on the paper here. So there it is, Huddy. That's me. And write down the abbreviation for the 4 tests for triangle congruency. Well, you can match up the 3 sides, SSS. You can have 2 sides and then the included angle, or you could have 2 angles and the corresponding side. Should put a C there somewhere, either next to angle or next to the S, because you have to have them in corresponding positions, and then a right angle triangle with a hypotenuse equal on one other side. Okay, how'd you go? Here it's, if you get 1 incorrect, you lose a mark. And if you get more than 1 incorrect, you lose all of the marks. Okay. Question 2. 2 of the following triangles below are congruent. Circle the appropriate 2 angles. Well, you've got 2 angles and a side which match up, but watch it. It's got to be the corresponding side. So this side is opposite the little star. This side is opposite the x. This equal side is opposite the x. This equal size opposite the unmarked angle. So it's these 2, isn't it? They must match up. Angle, angle, and corresponding side, if you like. So there's 1 mark for circling the 2 and 1 mark for actually putting the reason, corresponding sides there, angle, angle, side. Let's go down now and have a look at the next one. So here we are, ABC is D is a quadrilateral. Calculate the value of P. Now with deductive geometry, the important thing is you must use all the given information and also try and relate it. So it's the sum of angles of a quadrilateral, isn't it? So let's add them up. 77 plus P plus 80 plus 92 plus 135, take 2P, must be 180. And the reason should be there, sum angles of a quadrilateral. It's deductive geometry, making deductions and given reasons. Oh, not 180, that's silly. 360, it's a quadrilateral, mate. So there's 1 for that, 1 for the reason, and then this implies 384, take P is 360, and therefore neg P would be neg 24, P would be 24. Okay. How did you go with that? Let's mark that now. 1 for simplifying and 1 for that. Total out of 4. Anything missing, you lose 1. Be hard on yourself. This is mathematics, exact and deductive here. All right, so here we go. Question 4. Have a look now. Show that the following 2 triangles are congruent. Well, I guess we would try to go for the right angle triangles. Are the same in both. The hypotenuse are equal. Remember that's opposite the 90. Okay, and one other side. So we need to actually list that out. So we will say in triangles A, B, C, D, E, F, just mentioning what we're going to do now. And we've got angle CAB equals angle DEF equals 90. And that was given, all these were given, AB equals EF equals 9, and that was given, and also BC equals DF equals 12, and that was given. Therefore, triangle ABC is equivalent to triangle EFD in order. The order must be correct, and right angle triangles hypotenuse equal on one other side. So that's what it looks like. It's showing or proving that they are congruent. So you must have these orders correct. So you're showing the equivalence of them, okay? Because angle A is not equal to angle D. So you can't have A, B, C and D, F like we started with. Start like this is okay, but at the end it must be in the relative order. So there's 3 marks. So there's 1 mark for matching up this and then the order and the reason. So that matching up is only worth 1 mark. Total of 3 there. Okay, how are you going? Let's keep going now. Question 5. It's given that the 2 triangles are similar, circle the correct ratio. Let's have a look. Well, first of all, there's an angle that's equal, okay, and then the other 2 angles are equal. So I've got to sort of turn this around so it lays on top of JKL. So the angle Z equals angle J, and the angle X equals the angle L. Okay, matching them up like that. So what angles would we compare? If they're similar, you've got to compare corresponding sides. So here, the JL side is equivalent to the ZX side, isn't it? The side on along which you've got 2 equal angles on either end. So we want to compare JL with ZX. JL with XZ would do. There it is. And is it true that that would be equivalent to JK and YZ? Would they be the same? Just let's have a look. JK is adjacent to the X in this one and opposite the star. So here YZ is adjacent to the X and opposite the star. So they are corresponding. Okay. So here there are 2 marks for that. That one and that one, if you like, 2 marks. So give yourself 2 marks, you've got that. You must match up the corresponding sides, remembering that one is produced from the other under a transformation of enlargement if they are equiangular and similar. Okay, question 6, state whether the following triangles are similar or congruent and give a reason. Okay, so we seem to have a lot of equal sides here. We've got those equal, and yes, the included angle is equal. And all you had to do was state it here with a reason. Triangles are congruent, and give the reason, SAS, and so there's 1 mark for that. Hence determine the value of Y. This was a little bit tricky, because if you match this up, you've actually got to flick this triangle over. So Y is not 47, Y is equal to that one. Okay, can you see that? You've got to match them up in perfect order. So triangle ABC, if you want to do this, and DEF don't match in that order. A triangle ABC is congruent with triangle. Now A is equivalent to D here. All right, see that. Okay, and let's do AB. AB is equivalent to DF, so this is DFE in order. Therefore, this Y is the F angle, which is equivalent to the B angle. Matching up, be careful. So it's 180 minus 51 minus 47. Oops, put 49. 47, which is 82 degrees. So there are 2 marks for that. If you did the working, if you got the answer where 82, it's 2 marks. So watch out for that. That's a little bit of a trick there. Okay, let's come down and have a look at the next one. Question 7. Shape below contains 2 similar triangles. Determine the value of X, showing clearly you're working out. So let's have a go at that. Now, it's similar triangles, so we should put now what the ratios are. So if you call that the centre of enlargement, this triangle has been, if you like, enlarged out to there. So let's look at it. 4 has been enlarged to not 8 but 12. Remember, it's an enlargement, so you're thinking of the small triangle being stretched or enlarged out to the big one. So that's where a lot of people go wrong. You can't have 8 here, so let's tidy this up a bit. The idea that this side has been enlarged to that. 4 is to 8, not 4 is to 12. And this side would be enlarged to that. And this side would be enlarged to that. So we can put X over 5. Okay, so there's 1 for that. Sides are in the same ratio. So put that in, same ratio of corresponding sides due to enlargement. And so that means multiplying both sides by 5, 20 over 12 equals X, or 1 2/3, but not essential to do that. So 3 marks will be those 2 points and this one. So the ticks are a mark as usual, so check those. Okay, 3 marks. Let's go down to question 8. Hope you're getting some marks here. Now question 8, consider this diagram, prove that the triangle ABE is similar to triangle CDE, and giving reasons for your answer. So let's state it in triangles ABE and CDE. Let's see if we can get some equal angles here. So we could say angle AEB, that's that one, equals angle CED, this one here, and the reason is vertically opposite, like that. Then angle BAE equals, now BAE is this one, called alpha. BAE equals CDE, down here, equals CDE. What are they? alternate angles. Now, did you get that? Or did you forget to use this here? Use all the given information. Be careful that you look around the figure and everything given must be used here. Okay, an angle then ABE would be equal to this one here, would be equal to this one here. So ECD, and that's sum of angles of a triangle, if you like, or alternate angles again. Therefore, let's match them up. Triangle ABE is similar to, and you can use this if you like, triangle DCE. Look out, it's DCE. Must have the order correct there. Equiangles, if you like. Must have this order correct, showing that A matches with D, not with C, for example. Okay, so there's 4 marks, so we get these 2 match-ups here, and then the order and the reason. Be careful with those 4 marks that you actually earned those. Okay, come down now. Hence determine the length of the side marks. X, well, x over 3 would be equal to 6 over 2. Let's just go back up and see that. X, EC corresponds to BE. That's how you get that match up, okay? So that's important, okay, matching up those sides. And then we've got the 6 over 2 corresponding sides. That's why this is important, to match up corresponding sides. Okay, so that means x is equal to, multiplying both sides by 3, 18 over 2, or 9, for example. So that, and then 1 for the answer. Make sure back up here you get the order stated so you can use your similar triangle result. Okay, come on down now and let's have a look at some of the harder sort of deductive reasoning ones here. We've got to be careful to use all the given information. Okay, so let's have a look at the first one. Here, the connection between these two, they are sitting or subtended by the same arc. So y is a half of that, 59 degrees, because the angle at the centre is twice the angle at the circumference. So we will just put that for the moment. You must give a reason that points clearly to the theorem that's involved. Okay, so abbreviations are okay. So what have we got here? We've got a similar thing. X is sitting on this big arc here, isn't it? There it is, sitting out there. So the angle at the centre sitting on the same arc would be that reflex angle, and that would be twice x. So let's work out that reflex angle there for a start. So the reflex angle is, we could put what? Reflex FOG. Reflex angle FOG is 360 minus this, which is 250 degrees. Some angles at the centre, some angles at the centre if you like, and then x is half of that, which is 125 degrees angle at the centre, twice the angle at the circumference, but angle at the centre theorem. Okay, so there's only going to give you 1 mark. Same theorem, just be careful that x is sitting on this back arc, and so it's got to be that reflex angle at the centre sitting on that arc, because 110 is actually sitting on the minor arc, FG there. It can be quite confusing that. Let's have a look at this next one now. Angle CBG is the first angle we might try to get in there. Okay, so that's CBE, I think we would try. Let's do CBE first. We'll get rid of that one. I think come in here, because that's vertically opposite, using the 116 and putting a reason. Okay, and we're in there now. We can see sum of angles of a triangle. X is 180 minus these two that we've found. Minus 26 minus 116. sum angles of a triangle. So that equals now 38. Bit more work in this, so there's one for getting that 116 into a usable place. Remember, try and work all your given information towards the end of the figure that you're working in, and then apply a theorem, and there's that one and that one. So we're going to give you 3 for that, so you must have at least one reason here. In these, oh hang on, there was just 1 mark and 1 mark. No reason, no mark for these 2. Okay. I'm going to be a little bit more lenient on you over here. You must have at least one reason. You should have reasons for every deductive step. That's what deductive geometry is about. Now this whole question, 6 parts, is worth 15. So we'll come down and look at the next 3 parts now. So let's have a look at this first one. And we've got here, what can we do with this? Well, alpha here, let's put in an angle alpha here. I want to use this down with the other information. So I've got to get this 51 having some consequence down here. And of course, there's the same arc. Alpha is equal to 51, subtended by the same arc. Or you can say angles in the same segment. Now we're into a triangle, so that was useful. We got this information down here. And so x plus 51 plus 46 is 180 degrees. Sum angles of a triangle in brackets. That looks like 88 now, so it's 180 degrees. And therefore that implies that x is 83 degrees. Okay, so we've got that one and that one. All right, let's come across this very busy figure here to get k. We need to work some things into the same triangle. So I reckon I'll try and get this one, call it beta, and this one. Let's start with alpha. Can you see that 18 and alpha are both sitting or subtended by the same arc BC? So alpha equals 18 degrees, subtended same arc. And then B, trying to use the 57 now, beta is 180 minus 57, 123 degrees. Sum adjacent angles on a straight line. Come to that. And now we're into this figure here, DBT is a triangle, so K plus 18 plus 123 is 180 degrees, sum angles of a triangle, and if we add that up, K is then 39 degrees. Okay, so there's one for that, and really no, the mark is really up here. Hang on, let's get this right. That mark and that mark. 3 marks there. Okay, the last one's a bit longer. I think there's 5 marks in this one. You can see there's 2 letters to be found. Let's look at X first of all. Well, only because it comes first in the alphabet probably. Or you might see that X is subtended by arc EH, and so is this angle at the centre. So X is 33, angle at the centre is twice the angle at the circumference, subtended by the same bit of arc EH. Now, what have we got? Look at O, that's a piece of information. The O is the centre of the circle in our convention here. So EOG is a diameter. All right, well, what can we say then? GFE, angle GFE, will be 90 degrees. This one here, angle in a semicircle, because we've spotted that diameter going through the centre. So that's important in circles not to forget that. So angle FEO now, can we do something with that? That's in a triangle, so that's sum of angles of a triangle. Let's just have a look at that. FEO Let's have a look. FEO down here. Okay, and the 90 and the 36 have to add up to 180. So there's a common sort of thing happening there with sum of angles of a triangle being very useful. FOE, let's try and get that. Now FOE is this one in here. Can we get that? I think so. That's going to be, let's have a look at it. It's subtended by FE, and so is the 36. So therefore, FOE will be twice 36, angle at the centre theorem. Angle at the centre theorem. Okay, so it's getting very messy in that figure. It's only a small figure. Maybe should perhaps draw it a bit bigger. And so now, what can we do? Well, I think we can do sum of angles of a triangle here, because let's rub some of this out. What have we got? We've just found this one, okay, and we've got FEO, this one, okay, and so we can find y. Y plus 54 plus 72 equals 180, sum angles of a triangle again. So y is 54 degrees. A lot of work, that one, and quite hard. So let's do it a mark there, each sort of deductive step, and what have we got? 4 and 1 for the answer. Okay. Now, if you miss more than 2 reasons missing, deduct a mark. You can miss 2 without a penalty, because there's lots of reasons in there, but you must put a reasonable number of reasons. Reasonable number of reasons, yeah, fair enough. Okay, so how'd you go? That whole question was out of 15, the 6 parts. All right, fairly challenging, that stuff. You must have a process by which you can unravel the given information and get an answer there. Okay, the diagram below shows a quadrilateral with both pairs of opposite sides equal. Show that it's a parallelogram. So this is a useful application, isn't it, of congruence, I think, here. So what we're going to do is we're going to go to triangle ABC. So this one and this one should be able to be matched up, I think, in triangle ABC and ADC. Let's match them up. AC is common to both triangles. AB equals DC, that's given. AD equals BC, that's given with these equal marks there and there and there. Okay, therefore triangle ADC is congruent with CBA, and that's side, side, side. Just watch it now. B is out here, and that corresponds to D, and A to C here. So just put that there, I can't read it properly. So these match-ups must be correct in showing congruence. We've matched up 3 sides. Therefore, what can we say? Angle DAC, D to A to C, will be the same as B to C to A. You're going to use those match-ups to get equal angles, because what is that? DAC, that angle, and BCA are equal and are in alternate positions. They're equal in alternate positions. Therefore, AD is parallel to BC. Okay, and so you could also here similarly do match-ups. Similarly, AB is parallel to DC. These two, this one up here, AB and DC, because you can match up BAC and DCA in here by a similar statement here. So therefore, opposite sides are parallel, ABCD is a parallelogram. Parallelogram. And you should put, because it was approved, as required. Okay, all right, let's have a look at that. For the matchups up here, 1. For the correct statement, order is important. Here you must have the right order. And then you've made the statement here that these are in alternate positions, therefore you've got that, and you could also do that. So there are 5 marks. You must make some reference to being able to do the other 2 sides in the same way, similarly, by matching up their angles. All right, how did you go? That's the end of our little test here, and that one was worth 5, yep, so you should have a total of 45. I hope you got a few marks there. Pretty challenging stuff, deductive geometry, remembering to use all the given information and also to work across a figure or down a figure, up a figure, so that you gradually get all the information together in the deductions in the one area of the figure so you can make a final statement. All right, good luck with the proper tests and any exam you might have on deductive geometry. It's cheers from me.